All right, once again, welcome to everyone on this edition of the Kubevela Community Call. Um, I'm Anoop. I've been running this for some time now. We don't have too many new people joining in. I think I see somebody called Devyan. If anybody's new here, you'd like to introduce yourself, that'd be great. Guess nobody's new. All right. Um, so to start off with the agenda, the biggest one I think we are all excited about is the cluster provisioning KEP we've started off, which started off as a very small endeavor to think how we could use Kubevela for creating fleets of clusters. But then now that's become quite a big intent in its own. We'll be taking a stab at it once we have collected all feedback, and we are waiting for obviously feedback and reviews from all of you in the community. The link to the CAP is there in the Cubera channel, and please do take a look. There are already a few comments, and I've been taking time, and my team has been taking time to look at them and review and respond. But if there are more and we can make sure it is driving in the direction where the community would actually benefit from all of these features. And there's quite a few, so it won't all happen in one shot. It will happen iteratively, and we'll be looking at what is the minimum scope to entertain, and then going forward as a plan for attacking this large scope. Uh, that said, this is still a proposal, and as we implement, we might see certain things that we might want changed because of implementation or architectural problems, and we will respond to that and update the CAP accordingly. In the meantime, I do know that we have Sergey from Comcast. Hey, Sergey, great to see you.
Oh,
Uh,
yeah.
And would you be able to show the rest of your demo from last time, or
Mhm.
are you?
Yeah, absolutely. Just tell me how much time do you want to use for it?
Absolutely. Let's come back to you. I just want to take care of all the updates at this point.
Mhm.
And Brian and Chaitanya and Ayush have been working a lot on the dev kit as well. So dev kit is almost complete. We have released 3 alphas so far, fixing bugs as we find them and use them within our own systems. We are hoping to release that as a GA very soon. Once that's done, we should have 111. But for the kept cluster provisioning, we are considering that it would build a lot of other ecosystem changes as well. And we are considering that probably 2.0 for Kubevilla is probably overdue. Um, that said, again, it's a discussion. We're waiting for what the community feels. And Brian, over to you on the Helm component updates that you want to give, and anything else that I know you've been working on.
Um, yeah, so one clarification, I've actually been pretty hands off on the dev kit, so all credit for that goes to the guys, and they've been carrying that one forward. But yeah, the Helm component then, Ayush and Vishal have been hard at work getting that over the line. So there was a few issues, but they've got most of them resolved. So you will be able to natively render Helm charts and put them under Qvela ownership with Qvela health evaluation and then all that built into it, which reduces the kind of dependency on Flux for a lot of the other add-ons. And also should simplify longer term the installation of the workflow and other built-in Qvela add-ons, because we kind of had a chicken egg problem where you install Qvela, but then the add-ons required you to have Flux, and if you didn't have Flux, you couldn't install the add-ons for the other Qvela products. So kind of resolving that chicken egg problem. So that is Ready, the guys are just kind of doing last minute determination of whether it should go into 111 or whether we should wait till 112. Waiting till 112 would give us more time to get some caching issues resolved and some security built in. At the moment, you can only consume a public repo, but the plan obviously longer term is to have authentication and all that good stuff built in. Any questions on that?
Just one comment. I think it might be okay to do it iteratively in 111 as well, because then we can have a clean cut of 111 alpha with some features of the Helm component available, with known issues being highlighted, and we could continue towards fixing those as we go, so
Yeah.
that we don't have to do any Git branching gymnastics.
Yeah, no, I don't disagree. It's just we'll obviously have to put an Alpha 4 out and do some testing and all that, so it'll delay 111 very slightly, but if we feel it's worth it, then yeah, we can do it that way.
I think it will be, because then one level will be substantial, and this would feed into for the cluster cap. I think that would be a big part of it. I think so. I think having that dependency taken care of early would be awesome.
Yeah. So on 111, the other big features, obviously DevKit, and we've kind of gone into depth on. We've also got the application policies, which kind of make policies configurable for the first time. So you can now modify components, traits, or components, traits, and workflows through application policies in a configurable manner. So that should help with some kind of application and organizational governance.
Could you
Um,
could you give an example use case?
Yeah, so our big one is the governance tag. So we have governance labels that need to be applied to every single component, and they're kind of universal. And what we're finding is teams are having to input them into each component, which is fine, but a bit laborious and a bit repetitive. So this would allow you to say write an application policy for governance where you specify those values once, and then that will actually be able to modify the components during revisioning and insert those. Governance labels universally into every application, or you can do kind of fancy stuff. It's QX enabled. So you could have a global policy that reads from a particular config map based on a label. So you could have like a service name label. That service name could be picked up, and then we reach out to like a backstage instance for metadata, and then that metadata gets inserted into the application, or you enhance labels or annotations and these kind of things. So it's pretty powerful in what it does, but it's pretty advanced as well. And then application policies can be done either inline, so like any other policy you would use, or they can be applied globally. And a global policy will take effect across your entire application fleet, and you can use that for like more platform level governance.
Yeah, so that reduces a lot of boilerplate code that you have to otherwise repeat within, or bake it into the, otherwise people have to bake it into the component itself. This keeps it flexible, and you know you don't need to be a YAML architect or write too much YAML either.
Yeah. There's also the post dispatch feature is now available in 111, so that will allow you to pass outputs from the component that a trait is attached to, so that you can actually read the outputs. Gautam can keep me honest on what the exact use case was for that. I think it was EBS.
Yeah, it was for the file persistence. For example, if you want to render a specific output and then pass it on as input, for example, let's say someone is provisioning file storage like EFS. There's a dependency that I need to provision a cloud resource, then a PV. Until PV is there, then create a trait like PVC. So that wasn't there before, which we sort of wrote down.
Adding to the Gautam's point, it's that it can fetch the dynamic status of the component to make it more precise. So you
Yeah.
can get the status of the component into the traits status, any status field.
Okay, so I don't need to wait for a workflow step that does that. Instead,
Yes.
it's natively
You don't need to
available as
create a
part of
workflow.
the component.
Exactly. Yes.
So
Cool.
yeah. And then if anyone's interested, I have a few quick slides, not PowerPoint, but just bash slides on what we're planning for the next release. If people are interested.
Yes, please. This is a community call. We're always interested in what's next.
Okay. So Okay, so what have we got? So three major plan features from our side. We want to get add-ons done declaratively. We want to introduce source resolution or source definitions, which we'll go into, and then this concept of module versioning or API lining, which I think is kind of missing, and we're having to hack around. So we want to get that as a first-class concept in code.
Sorry to interrupt you, Brian. Are you sharing just the bash? We're just seeing Kubevela plant features and not any details.
Oh yeah. Sorry, this is a.
Okay. So, all
I'll go
right,
into more detail then.
go for it.
Okay, so yeah, there's three keps planned. We have the module and API line versioning kep 220. 2.13 is the declarative add-on lifecycle, and then 216 will be source definitions. Um,
Could you briefly explain what they are?
yeah, I'm going to go into it now.
Yeah.
Okay, so declarative add-ons. So the issue right now is that you need to basically use imperative commands to install an add-on. There's workflow steps that improve this, but they're not great. And you've no kind of continuous reconciliation or anything like that. So we want to introduce GitOps support through an actual CRD for add-ons that would allow you to install add-ons more declaratively. Uh, the underlying functionality would remain much the same. There is still an application rendered and applied to the cluster. Your definitions, etc., that are attached to the add-on will be applied. But you'll have continuous reconciliation, automatic version upgrades, and all these kind of good things. So yeah, main issues at the moment are no GitOps support. So the adoption of add-ons is kind of difficult unless you have an operator sitting at a terminal managing them. So the fix we're planning is to introduce an add-on CRD so that you can have CORs for your add-on. They'll be pretty much the same as using the CLI, so you'll have the version. We can introduce server ranging if needed, but we want to have an upgrade policy to prevent changes automatically rolling out, give you control. We'll use the existing registry system. This is all exactly the same as the CLI. Essentially, there's no breaking changes. There's no new features here. It is literally just making this declarative. And then all the parameters that you would typically feed into an add-on remain consistent. So we'll have the overrides, your topology groups, all that kind of stuff. So it's really just about making this declarative and enabling GitOps support for it.
And this would also feed into a cluster cap at some point as another way for people to install packages.
Yes, exactly. Um, Yeah, and again, we won't go into it, but like I feel the cluster plane concept is they are kind of applications, and I think that's where the kind of junction point to me is between a cluster and your applications. But we can get into that as we plan out that kit. Yeah, so you'll have tracking mode will allow you to do manual upgrades. If you set this to auto, obviously not recommended, it will automatically pull newer versions of the add-on continuously. Or you can set it to manual and you can have a specific pinned Semver for GitOps support, etc. Deletion policies then, I'm not going to cover too much, but we'll be able to either leave the application running and orphan it, or we can do a protection mode where we'll only allow the add-on to be removed when all usages of the application or its definitions are in place. So there's a bit more protection there. And then we can also ensure, obviously, through a finalizer that the application itself cannot be deleted while the add-on COR is still in place. So the add-on COR becomes the major control point for all kind of operations. This then kind of feeds into kind of better concepts like add-ons of add-ons. So at the moment, add-ons are very much like, fire and forget. And we want to get this into more like a compositional layer. So if you wanted to install Crossplane and all the different Crossplane packages, and there were, there's three different add-ons, we can actually use the existing application constructs through this to kind of enable, hey, I need the Crossplane add-on, but I'm going to install that first. And then I want to install the AWS and GCP providers for that. But, I want to wait until Crossplane itself is installed, and then you can start actually composing entire platforms through this. And then the Crossplane installation add-on itself can be another child add-on of, a larger platform construct and all this. So you can kind of layer your infrastructure. Um, that's kind of that. Any immediate questions on that? Cool. Okay, second one then is source definitions, which would be a completely new definition type. So this will complement components, traits, workflow steps, and policies. Uh, Kubevela does a pretty good job of enabling you to create resources. What we struggle with is, reading external data and actually making that easy to feed in. Uh, Typically, what is done is you'll have to use a workflow. The workflow reads from somewhere. You use data passing to read a config map or make your HTTP request, and then you feed the data along in the chain. And that kind of creates a hard dependency. Like a lot of our teams are having to copy and paste workflows from one app to the next in order to repeat the same kind of like config map reads or something like that. So we want to make configuration more of a, built-in concept in Kubevela. So we want to get rid of that repetitive orchestration logic. We want data reads to be abstracted as much as, resource creation. And we want to do all this in a type safe manner so that we can actually validate this. So we want to introduce is the source definition, which will look very much like the existing definitions. You'll have, your metadata and then the template. But alongside this, you'll also have a schema, and some storage concepts for where we're going to cache this data. And essentially, you will configure this. So this is an example of reading from a platform data namespace and cluster config map. And this is the output of that. And this output must conform with the schema that you've specified here. Behind the scenes, we're going to use config templates to actually drive that schema so that you can't return values that break the schema. And we're going to integrate with the config system that's already in Kubevela so that these are all, once these configs are created, you'll be able to use the existing CLI commands to actually view the configs, etc., that are being used across the platform. So there's nothing majorly new here. We're using as much of Kubevela as we can. And then what will this look like to the user? I think that's the important part. So when we define our cluster config reader source definition, the user can then just simply say, hey, I need a source of cluster config reader. That's all they need to do. It's completely abstracted away. There's no workflows, there's no anything. And then their components can reference any outputs from that source definition. So they can then say, hey, region from source, cluster info.region. And this is completely validatable because the schema has been specified up front. So we know that this takes a string field. We know that the schema for the source definition returns a string to these are compatible fields. And then likewise, we can do comparisons on the optionality of a field and the required fields that are going into the component. So for example, VPC is marked optional here. We can't pass an optional field into a mandatory component field because that may not be present. So you would have to then specify a default, and we can do all this validation at admission time because we're aware of both schemas. So it's pretty type safe. It extracts away the complexity of data reads, and overall, it kind of improves the security because at the moment, a lot of the built-in workflow steps allow you to arbitrarily read across namespaces and kind of access data that you shouldn't. So this gives platform engineers a way to say, hey, this is the data you're allowed to access. We use ORBAC to control what, definitions they have access to, and then it kind of
I was just going to ask that. So this is going to follow the existing RBAC for the user.
yeah, so it's the exact same as component definition. You can limit who can access, and then within that definition, you can limit, because you could read a config map with 100 values, you can limit it down to, hey, we're only going to return 3 from this. And then yeah, you can have more privileged versions of that, etc. But yeah, this abstracts away the security aspects of it and makes it all a little bit more secure, and also reduces greatly the number of workflows that you have to use.
Yeah, and this would sort of, I mean, I don't know if it solve 100% of OANA's config template request.
Not 100%, they still need to output from an application. So components can currently output, applications themselves can't, which is something else we have on the backlog, is like this concept of application exports, so that you can export from one app to the next. But you can technically, in the interim with this, use the feature we added for um, status details field. So you could read the status details and pass it from one app to the next. So that would kind of solve it short term until we get formal exports in.
All right, cool.
Um, Caching wise, I'm not going to go into the details, but we'll have a quick cache because we don't want to slow down rendering, and then we'll have the config cache, which will be a config map essentially, and then there's a TTL on that. And then if the TTL is expired, we'll execute the template. So you can kind of control how often you're retrieving the data and how fresh it is. The other advantage of this is it happens during render time. So if your data changes, you do not need to re-execute the workflow, etc. This will get the fresh data and then pass it into the component rendering. You get that, and then if you have auto update and all these features enabled, it will automatically roll out a new revision, and you get that data change immediately. And then yeah, we will support source chaining. So one source definition can read from the outputs of any prior source definition, and that'll execute in order. There's an example here of doing governance by label. So if I have a particular label on my application, I can use that to read from Backstage or whatever we kind of explained before. So this kind of accompanies the application policies feature. And yeah, we've kind of gone into the trust model and how a platform engineer has high trust access, can use QX, etc. But the application author is only able to use what is actually prescribed by the platform. And that's it on that one. Any questions?
No, looks cool. Anybody else have questions?
Cool. Okay. And then the third and last one, which I'll fly through quickly, is this concept of module API line versioning. So what we're kind of having to do is kind of have each definition independently versioned just using suffixes. So if we introduce a breaking change in one component to the next, you need to essentially upgrade to V2. And we essentially just want to make this a first class kind of concept. We describe Kubevela as the API into our platform. So we want to treat it like an actual API. So currently what you can do is use Semver, but users don't think in Semver. Developers think in Semver. Users just want to consume something that they know contractually going to work, which is much more in line with an API line, an API versioning. So what we want to do essentially is introduce this kind of concept of modules, so that you can have like an API group in Kubernetes. You'll have modules in Kubevela. A module can have many API lines, and then API lines will be able to ensure a stable contract for the user. So this will be a new field. Where have I got it? Yeah, essentially sorry, here. It'll be a new field on the definition spec. So version will still exist. You can still pin versions if you really want to, but this will be more safe and secure in terms of, hey, I just want to be guaranteed that if I'm pinned to version one, no matter how many updates or anything I get, version one's API contract remains stable and I can always rely on it. And then the hope is to enhance this, to be able to kind of say, hey, if you're moving from V1 to V2, we can have migration workflows and all these kind of concepts built in so that any workflow steps that need to execute before a component upgrades and all these kind of things can be built in. And this gives the acute awareness that the API version is changing. And then also because we're aware of the API versioning, we will be adding validation to the API line. So if you try to introduce a breaking change and the API line remains consistent, we will be able to block that. So if you add a new mandatory field, or you add additional value, or if you restrict the values in an enum or anything like that, we'll be able to block that change and say, hey, this is not compliant. You're going to break the API contract. You need to create a new API line. Other than that, most things remain the same. If you're opting into this, and it is a completely opt-in feature, the old stuff will continue to work. You will now refer to your types using a more kind of fully qualified path. So it'll be something like Postgres /v2/database. Which will give you a little bit more consistency, and we're planning for a little bit more control over like attaching traits between API lines and these kind of things. And this should help reduce breaking changes in your add-ons as you roll them out, because it no longer just, arbitrarily replaces definitions or creates new revisions. It will actually have this API concept built in. We'll have deprecation kind of concepts built in as well. If an API line moves from enabled to disabled, we'll deprecate it, and then platform engineers will be able to see what's deprecated and then make the decisions of when and what, how to remove them. And that's kind of it. And this will also be built into the add-on structure. So add-ons will be the distribution mechanism for modules. Modules can be either Q or DevKit or any combination of both. So your
I was just going to
V1,
say that because this would neatly fit into a Go versioning model
yeah,
for modules.
yeah. And the modules themselves within an add-on can be external references. So you can import a module into an add-on. So you can kind of say, hey, V1, I want to import from an external repo and that's Q-based. And then for V2, I want to import from a different external repo and that's DevKit based. And it kind of gives you an easier transition path from one to the next, etc. And you can choose, what you're adopting and when. Um, and that's kind of it. As I say, this is a complex feature. It's a big change, but it's completely opt-in, so it's not going to break anything that already exists. Any
Cool.
questions?
Anybody have questions on this or anything else in the Kubevela world? Because after that, we're going to go to interesting Sergi's talk. I want to make sure that I take care of all the questions that people might have. Nothing? Sergi, how about 15 minutes?
Okay.
So do you mind giving a brief about what you're going to talk about? And
yes, can you see my presentation?
Yep.
Yeah, it's also napkin sort of driven, but this is part two. In part one, we were talking about how we are using Kubevela to manage applications distributed across multiple sites, multiple locations, multiple regions. And today we want to focus on cluster management, which is very well in line. In a Venn diagram, there is a lot of overlap with the cluster info cap. So definitely looking forward how we can work together on this. So a quick intro. So Comcast is a global company, tons of applications, many teams. We are very early adopters of a Cloud Foundry, running it for more than 10 years. And Cloud Foundry is sort of perfect for microservices. However, we want to extend to other journeys. So we are doing a lot of Kubernetes-based platforms. And for that, we need to deploy Kubernetes. So what we are going to talk today is how we are leveraging Kubevela, not just Kubevela, but Kubevela is a big part of this, of our ecosystem, to deliver clusters, Kubernetes clusters at scale. These are some basic terms. So Bossa Nova is our internal product for to manage opinionated user experience, essentially CRDs, CRs. So it's you can see it as close to Croc project, but just it was created before that. We might want to revisit. We are using Kubevela mostly for templating. In some cases for continuous delivery. However, we are partially switching to introduce Svelte's project to it. And definitely we have a tons of specialized controllers. But the bottom line, so this architecture is a uniform control plane, not just for specific tasks like Kubernetes cluster provisioning, but for other things, application deployments, databases, and so on. So focusing on a cluster, these are main components. So the Bossa Nova is a translation of is that UX level, which means that the customers do not have access to directly OAM, to directly Kubevela objects. So customers work with more opinionated front end, and I will show examples of this. Kubevela is orchestrating and composing final objects that needs to be pushed to clusters. We are using Cluster API for the actual cluster lifecycle management, and Svelte's for add-on management. Again, at some point we used Kubevela also for add-on management, but we are shifting, back and forth, depends on specific purposes. And finally, we have tons of other applications deployed on those clusters. So again, connecting to cluster infra cap, one of those add-ons can be Kubevela itself. All right, so the UX level. So UX is essentially takes a CRD, and again, I will show example on the next slide, and apply blueprint to actually generate a Kubevela application. Blueprints are managed by the platform team, and consumer only interact with this through the CRDs, through the custom resources, not through Kubevela resource. And here is an example of that contract. So when somebody wants to have a cluster, the cluster can be on a different infrastructure. So we have a separate like OpenStack, AWS cluster, and so on. So they provide a name. Now this version here is very well in line with what Brian was just talking a few minutes ago. So we're also trying to figure out how we manage lifecycle, not just Kubernetes version, but how we manage lifecycle of the whole product. So these things are important to point to which infrastructure you're going to provision. So here's an example. We're using, some Snap project is Cloud Native Application Platform, just our, internal name, and, some region where we're deploying it to. And then you need to provide all the details specific to this infrastructure. Now I removed everything that is Kafka specific, so it's not a real example, but pretty close to real. Who has access to the cluster and so on, and what is the size? So how big the control plane is, how big is how many different node groups we have, and so on. So,
Sergey, if you don't mind, I have a question. So where would you define some of the prereqs? Like, so, let's say it's on AWS, you need a VPC, you need to set firewalls and all those things. Is that also part of this, or is it done outside of this?
Good question. Actually, yes, it is. So it is sort of part of it. We have another object called OpenStack environment.
Okay. Got it.
Or well, OpenStack region or AWS region. So that defines these pieces over there. And it depends on what we are running. It can spin up cross-plane to provision specific objects on OpenStack, on Azure, on AWS, or vSphere, whatever infrastructure is in. So yes, prerequisites needs to be there for sure, right? And also credentials to access that infrastructure also needs to be there. And those credentials are also delivered through the same mechanism, and you can either provide it through a secret or through integration with some kind of secret as a service. So you can say, hey, I have a vault, and in this path, you need to pull these credentials. So you can have a central place to manage them.
Okay.
Good question. Yeah. So when a customer applies this, what customer do not see is that behind the closed door, it expands to this much longer application object, and so now it creates an application with a similar name, where all meat is, right? So we have components and traits that is developed by the platform team, and really using that composable way to express what we need to deploy. So here you can see some examples. So the component is just cluster API cluster in this case. You see it even not specifying that it is for OpenStack or for AWS. But then there are different traits, and one trait may be OpenStack infrastructure, right? So this is where all the details about infrastructure are going to. So the same cluster component, copy cluster component, can be applied to different infrastructures. So it is pretty universal. So this way we built our library in a very nice way, again, thanks to Kubevela and this very nice structure. So you can see other add-ons like, hey, you need to deploy CNI. So we put Cilium and again, some details how we're deploying it. We need to configure BGP. So again, some details how we're doing it, and so on. So we can build clusters from these components and traits exactly the way we want. But as you see, this becomes pretty long and hard to manage, and also hard to upgrade, how to manage upgrades. So that's why we really want to have a customer contract more simple like this. So that's pretty much the what we have, right? And the workflow is customer provides a custom resource based on our specs. Then this custom resource combined with the blueprints and created Kubevela application. And then Kubevela application is spinning up different objects that required for provisioning. That can be cluster API objects or Flux CD objects or whatever is needed. So for day one, day one is important, but day two is always more important. So again, the idea is simple. Customer updates, the CR reconciliation happen. 15 minutes later, you have an upgraded cluster. And again, we are using combination of tools for this, and Kubevela is very well in the middle. And the same technique, as I mentioned, is applied to cluster as a code, to applications that we were showing 2 months ago, and databases as well. And this is, some motivational slide why we are developing this architecture, and why we have customers who really likes what we are doing and growing. I think that's pretty much it. Yeah. Oh, yeah, a few lessons. Right. So abstraction is definitely an important thing because of a lot of details in Kubernetes, a lot of details on Kubevela. So we want to have a very clear abstractions that are easy for customers to understand and validate and enforce. And this helps to have a platform team developing all the recipes, and large number of users are using it.
This is awesome, Sergey. I think when we started off the KEP for the cluster infrastructure, we had the exact same principles in mind, and more so. I think we would want to lean on a lot of your expertise and experience as well to shape that KEP in a way that would be useful for Comcast and for everyone else in the community. So, looking forward to more interactions, maybe outside of the community calls. We could probably get in touch once in a while.
So sounds good. Yes, we have. I want to say we are very open, but we are enterprise company, so to open source anything actually
We
takes
understand.
a lot of hoops to jump through. But definitely we are eager and want to work with community.
This is awesome.
I think even outside of the cluster cap, I mean, I think we're even seeing from our internal apps, like, there's a huge amount of reuse and same patterns across different microservices. So there is a cap open even outside of the cluster for more of a application blueprint or an application definition as well. So definitely goes way into that, and then I think that application definition then becomes part of the cluster cap and spec, and then we evolve it that way. But
Yeah, so I sort of like what Sergey said about recipes, right? I mean, for the applications, if you can have like recipes, like, combining what you're saying and what he said, if we take, we have blueprints for the cluster infrastructure cap. If we had blueprints for application, which is what I'm understanding as you're saying, then there is very minimal work for the user because, that's a golden path, paved path that people could just trust that
yeah.
works.
And then the cluster planes, essentially, you're kind of just application blueprints as well, and it all starts to tie
We could
into
apply the same principles both sides, yes.
Oh, I do have a comment from a cap, right? So I didn't read it carefully, but just a quick review. So I see that you have a proposed architecture with like a one jump start cluster that creates more other clusters.
Right.
And then and we had the same model in mind, but then how we are going to manage this jump start cluster? That's a
Yeah.
big question. So we actually ended up with merging chicken and egg, and we have like two clusters that manage each other. So when we jump start cluster A.
Okay.
Then from this cluster A, we jumpstart cluster B. Then we very carefully move objects from the initial jumpstart for cluster A to cluster B. So then we have cluster B manages cluster A, and cluster A manages cluster B. So we have the same objects that you saw. So when, for example, we need to change size of cluster A, we are going to cluster B and say, hey, just add more nodes, or upgrade Kubernetes version, or upgrade Cilium version, or something like this. And same, if we want to manage cluster B, we can do it from cluster A. And then those couple of initial clusters can spin up, the leaf clusters as many as needed. So this is sort of a chicken and egg problem is very real, and that's how we are solving it. And it doesn't have to be two; it may be three. It may be.
Yeah, it can be federated. But that's an interesting thought. We want to start with the simplest thing that we can get to, and then we can look at what options do we have to be able to manage things in a much more robust federated manner. Because obviously it won't be for big companies like Comcast and in some cases even Guidewire, we won't, one hub may not be enough. You will need a federated set of hubs. Now, how do you manage them? So this sort of like helps in that direction. But for now, we're going to start with a single hub and then with the cap, and that's probably another cap in itself because this cap has already become so big that sometimes I've forgotten what I've written. So I want to get this over with, and then we should start another cap. And hopefully, I'm hoping for a cap from you, Sergey, that will help us, align and discuss and with the community and implement that.
I've been referring to it internally as your mega cap.
Well, mega is probably small as far as for this particular cap. But it was a lot of fun. Weekends think one thing and then it's monkey thinking, right? Jump from one to the other. Why can't we solve this and solve that? But then they were all in the same realm of things that need to be solved as a fleet management. And that's why this cap is big, but we will not be implementing it whole. We'll be implementing it in phases. And that would be a big part for 2.0. I think Kubevela is due a 2.0 at least. Cool.
Yeah.
Anybody have any questions, comments, updates they'd like to give? And thank you, Sergey, very much for this presentation. This will be recorded and uploaded on the Kubevela YouTube channel. We will reach out once you started, a little bit of the work on the cluster cap on ideas that you might have. But otherwise,
Thank you. It's a great community, and we really, happy to use Kubevela as a part of our
Awesome.
for supply chain. Yeah.
Anybody else have any comments, updates?
I just a minor one that the alpha docs should be available for V111 as soon as you get around to merging, and then it'll
Yeah, so that's waiting for the PR to be merged, right?
Yeah, there's a few issues with the doc chain, so I fixed that. So there's two PRs open, one to fix the doc chain and one for the docs themselves.
Okay, I'll take a look at it right after this. But otherwise, well, have a great afternoon, evening, morning, all of you, and see you in the next community call.
Thanks, guys.
Thank you.
Take care.
Bye.
Bye.